Whenever we have a reflecting surface and the moment light from somewhere hits that surface, it will always follow the law of reflection. That is, the angle of incidence is the same as the angle of reflection when it comes to the measurement. These angles are measured when the rays are lying on the same plane. We have seen that when we did discussion of the image formed by plane mirrors in our last session. It doesn't matter what the shape of the mirror is, the law applies to all, may it be a plane mirror or a curved mirror. What I have on the screen are the two types of curved mirror. This is a convex mirror and this one is a concave mirror. When the reflecting surface is this bulging part of the mirror, it is a convex. When the reflecting surface is here, it is a concave mirror. Let's focus on the convex mirror in this video. In my next video, I'll show you ray tracing techniques when we have concave mirror. On the screen is a diagram of a convex mirror with a principal axis, the center of curvature C, and the focus F. This arrow here represents the object in front of our convex mirror. When an object gets light, some components of that light will be bouncing in all directions unless blocked by something else. Interestingly, there are a few light rays from the object that is very easy to use, also commonly used by some teachers or most teachers and professors of physics. A light from the object, which we call incident light or incident ray or incident light ray that is parallel with the principal axis, always reflects in the direction as if it came from the focus. On the other hand, an incident ray that is directed towards the center of curvature will be reflected through the same path as the incident ray after hitting the convex mirror. An incident ray that is directed towards the focus will be reflected parallel to the principal axis. Alright, as you can see here in the diagram. These reflections of different incident rays follow the law of reflection. If we are to draw a tangent line here at this point and a normal line to that tangent line, we can see that this angle of incidence and this angle of reflection are going to be equal. Similarly, a tangent line here and a normal line to that show that these angles of incidence and angle of reflection have same measurement, which is 0 degree. Also in here, the tangent line with the normal to that line shows these two angles with equal measurements. We may also want to show another ray. See this. A ray from the same point in the object hits the intersection of the principal axis and the mirror. Using the law of reflection, we can show that this must be the reflected ray of light. These two angles are equal. Now, how do we find the image? Just as in the plane mirror, the image must be formed at the point of intersection of all the reflected rays drawn. However, when we extend these reflected rays, there is no way they will meet or intersect. These rays are divergent rays. In that case, we extend their tails and find the point of intersection. This one goes here, this one goes here, this one there, and this one here. Here is the intersection. You can actually find the point of intersection even with only two incident rays. We have 4 rays here. You can only use 2 and may want to draw one more to check whether your point of intersection is correct. All the incident rays came from this point in the object. Reflected rays meet at this point. This means that the point in the image equivalent to that in the object must be here. From here, you can draw the entire object. Then describe the image relative to the object. Now, what descriptions can we make? The image is smaller than the object. The image is upright. The arrow object is pointing up. The arrow image is also pointing up. The image is also virtual. There is no way you can project this image on a screen. These are the reasons why you always see these convex mirrors in some grocery stores and supermarkets around. The image is upright, and that because it is smaller, a wider area can be seen through the mirror. Okay kids, let's go back to the video conference room via Meet and do some practice on using this technique using Google Jamboard.